Hey you guys, so today I'm going to be talking to you about part 2 of exponential functions. Today we're going to be looking at some of the graphs of exponential functions. So I've got some pictures here on the screen as well as some notes to help you to follow along and see it visually rather than having to watch me draw the graphs, because I know that would probably make things a little more difficult than it would be to see it on the screen in front of you. So here at the top we've got just two basic graphs of exponential functions. This first one here on the left is the graph of f of x equals 2 to the power of x. And then the second graph over here on the right is f of x equals 5 to the power of x. So both of these graphs have some pretty similar features. You'll notice that they both look kind of flat on this left-hand side. It looks like it's actually almost turning into a straight line over on that left-hand side. It's not exactly, but it kind of looks like it to our heads. And then as we go to the right, they start to increase and the graphs start to get steeper and steeper as they go up higher and higher. So both of those have some pretty similar features to them. So we're going to talk about what some of those features are. So the first feature we're going to talk about is called an asymptote. So an asymptote is a line that a graph approaches as that graph goes to infinity. So what that means, if we look up here at this graph, as our graphs start to go to infinity, so as we start to go towards negative infinity, so going towards the left here, notice our graphs are starting to flatten out. So that spot where your graph starts to get flatter and flatter, it's getting closer to a line. It's starting to approach it but not cross it. So since an exponential function, it gets closer to a horizontal line, we call it a horizontal asymptote. So exponential functions have a horizontal asymptote, which is a horizontal line that the graph gets closer to but never crosses. So it's going to get closer and closer but never actually cross over that line. So we've got a picture of a graph down here with the horizontal asymptote already sketched in there for you so you can visualize it. So this graph over here is an exponential function, and it has a horizontal asymptote at y equals 0. So y equals 0 is right here. This is our y-axis, so when we look for where it's 0 on the y-axis, that happens right here, which is where this line crosses it. So that's y equals 0, that dotted line. And notice as this graph starts to go towards negative infinity, it starts to go to the left, on and on forever, it starts to get closer to that dotted line. So that's why that dotted line at y equals 0 is the horizontal asymptote. So now, I want to show you how to draw in some horizontal asymptotes on a graph. So starting with this first graph, notice if we're looking for the point where our graph starts to flatten out, it starts to draw closer and closer to that line. That's going to happen right here, right through this 2. So right here, there's this horizontal asymptote, and it's not the best drawn. You're going to have to bear with me. But there's that horizontal line where your curve starts to flatten out and gets closer and closer to that line. So when we write the horizontal asymptote, we would write it as y equals, and then it went through the number 2, so y equals 2. Now for our next graph, we're still looking for the horizontal asymptote. So we're looking for where that graph starts to flatten out. So looking down here, it starts to flatten out right here, right along this line. So that means that at negative 1, we've got this horizontal asymptote. So our horizontal asymptote would be y equals negative 1 for that graph. All right, so that's finding the horizontal asymptote. The next thing we're going to talk about is when a graph is 1 to 1, and this is something we talked about when we first started talking about inverse functions. So exponential functions would pass a horizontal line test. That means if we drew a horizontal line across any point in the graph, a horizontal line would only cross the graph one time. So it's 1 to 1. And if a function is 1 to 1, then it has an inverse. So we know that an exponential function is going to have an inverse, which is going to be important for us in the coming lessons as we talk more about what is the inverse of an exponential function.